Hi guys, welcome to this page of the notes. Again, what we're doing is we're talking about three specific kinds of parallelograms: rectangles, rhombuses, and squares. The previous pages of this notes, we've already talked about the special properties of rectangles, special properties of rhombuses. Now we're going to go ahead and take a look at squares. Here we go. A square is going to be a quadrilateral, 4 congruent sides, 4 right angles. We have seen both of these before. 4 congruent sides makes it a rhombus. Four right angles makes it a rectangle. So let me draw you a quick diagram here just to show you what's going on here with squares. This is really, really interesting. What we've got is we talked about rectangles and we talked about rhombuses. Now, a rectangle and a rhombus are two different figures, all right? Rectangles and rhombuses. A rectangle is not a rhombus and a rhombus is not a rectangle, right? They're two different figures. But what's interesting about these two figures is that they do share something in common, and what they share in common is a square. So you have rectangles and you have rhombuses, and where those two figures meet is a square. A square has 4 right angles and 4 congruent sides. So what that means is that all squares are rectangles. Why is every single square a rectangle? Well, because a square has 4 right angles, and all rectangles have 4 right angles. But all squares, every single square, is also a rhombus. Why? Well, every rhombus has 4 congruent sides, and every single square has 4 congruent sides. So rectangles and rhombuses, two separate figures, but where they meet, what they have in common is the figure we call a square. A square is both a rectangle and a rhombus at the same time. Why? Well, because it shares properties in common with both. Right? So